right, so I wanted to give you guys a walkthrough of the I-Ching sample. There's a couple of parts to it. Um, the Under the images directory, of course, is the ZK program, and there's a README. I guess yeah, it's okay with some source code. The Rust program just gets wrapped into a ZK program, gets deployed to my mini O S3 open source S3, and then gets downloaded back down by a prover to execute. And then there's the on-chain callback, which is in charge of persisting the ASCII hexagrams after the program gets run. And there's going to be a README under the scripts directory, I believe. Oh no, there's a README under the README directory that describes all of the derivation, the program derived address for the hexagram storage. And there's going to be a README for the ZK program. And then there's going to be a README for the core scripts to run the sample. So I tried to make this quite self-contained. The ordering is pretty clear from the numbered scripts. Actually, I should probably get rid of the generate input script. You're going to be running the scripts in order to build. So first you'll build it. After you've built it, you should then run the validator, and then you can run the prover node. Then you can deploy the program, which deploys it to S3. And then this will generate the input.json file that is passed to the program to run. And then you will execute, which basically tries to find a prover node to claim the program to execute. And so let's try doing that right now. So I've already built things, so why don't I just try to bin, and this will -r basically resets it so that I have to redeploy the ZK program. And what I like to do is launch another window here, and so once you see waiting for fees to stabilize, it's ready to go. And then I will run node.sh, and you can check the top portion for the flags. So I'm going to run the local instance, which is my version of the prover node with RISC-0 dev mode support. So what it does is actually does a sudo so we can set all the U limits properly. And you'll notice all the U limits get properly, and it does a recompile to make sure. Same thing with this running the validator script actually recompiles all the on-chain program just to make sure that they're all up to date. And so while that's building, I'll launch another window. The third window I like to do is to take a look at the local Solana node and just stream any program logs. And then I'll like launching a fourth window, and the fourth window is where I actually run the rest of the script starting from 2. So I've already done the build, so I will be starting from 2 to do the rest. And then for the prover node, you want to wait until it's done loading images, and then once you see this verify prover version, then you know it's done. So this is done, and now I am going to deploy the program. Hold on, images 8-bit 02. scripts o2 deploy .sh, and let's just check the script. So local debug. Okay, so now I know to go local, and yes, we will deploy. And you can check the log here to see that the deploy instruction was processed and that the prover node downloaded the image, downloaded and stored the image. Okay, and then the next step is to um, generate the input file, and you want to generate it with the callback, and there's no flags for that. And this basically funds the hexagram program derived address, the storage account for the hexagrams, and it does does some compilation of this init storage. This is a command line tool to initialize the storage account, and that's how you know that worked. And so let's see, storage. So this is it actually has to create the storage account through the callback program because the callback program has to own it. So yeah, that took a bit of time to sort of diagnose and fix. So now you can see that the storage account is initialized. And then once that's done, we should be good to go to execute. And let's just double check the flags. So dash dash local and dash dash debug again. So we'll go to images, 8-bit Oracle I-Ching, scripts, 04 execute, dash dash local dash dash debug. And this will again double check and make sure the binaries are up to date. So this is double checking that the on-chain binary is up to date, as well as the command line tool. And actually, you can just wait here. This is the Solana logs command that basically is snooping the the validator node, the local that's running on localhost, to check when when it actually executes the I-Ching program that generates the lines and the hexagram. So we'll just wait for that to happen. So instruction, the claim is claimed, and then now we know that it's been visualized. So this is the program. Okay, so this is the execution was claimed, and it was claimed waiting for it to complete. So since it was claimed by this node, we should be able to check. So here's the Solana Explorer. We've got to point it to our local host, and then we search for that account. Okay, and then we should hopefully be able to see um, this the hexagrams stored here. And so yeah, there you go. And so that's the demo of the on-chain callback that persists data. It doesn't actually do the proving and the verification and the snark to stark compression. Just because that would take too long, so had to add support for RISC-0 dev mode. So this whole thing is assuming is all set to specify RISC-0 dev mode is on. But this is just a good way just to make sure that the prover node is picking things up, that the claims are working, and the programs are executing, and so on. And so that's pretty much it. Thank you. Oh, my name is Augustine Chan, and this was done. Hopefully, we can do an integration between 8-bit Oracle and Bonsol when the time comes. Thanks.